Okay, so we are moving on with relationships. We are going to talk about the algebra side of it, right? So we've talked about the graphing, we've talked about the modeling, we've talked about the stories behind it. We're going to move towards algebra. So we're going to do 2 pages. The first page we're going to write on, the second page we're going to glue something in. So page 21 is relations and functions. And page 22 is the vertical line test. So again, relations and functions and vertical line test. And if you need me to pause or we're going too fast through notes, remember you can pause it yourself on YouTube and catch back up with us by pressing play. Okay, so page 21. This is entitled Relations and Functions. Okay, so relations and functions. A relation is a very specific thing. So the definition of relation, a relation is a set of values or ordered pairs. So it's a graph, right? It's a set of ordered pairs, numbers that represent a point on a graph that belong together. And the reason they belong together is they're not random. Like they represent something. Like they, over 2 up 4 and over 3 up 7 represents like the second person had 4 and the third person had 7, right? They have a story behind them. They're not just random things. And the reason and the way we can say that they belong together is they're inside brackets, which are those squiggly do, not parentheses. They're those brackets that, are really hard to make sometimes. Practice makes perfect. But they're inside brackets. So for example, 1, 5, -2, 3, 4, -1, 0, 7, -3, 1. That would be a relation. Those 5 ordered pairs belong together. They represent something together. So we don't know, we don't have this background story of what they represent, but I do know that they belong on a graph together. It's going to be a continuous graph because they're in a relation. The relation makes it continuous, so we connect the dots. So the relation is just this set of ordered pairs. This set of ordered pairs is called a relation. Inside of a relation, there are 2 more vocabulary words. There's something that's called the domain. And the domain, all that means, you just have to, kind of associate them together. The domain is a list of all x values in a relation. So the domain is the list of all x values. It's not just the x value, it's all of the x values. So if it says, what is the domain of this relation? Our example would be 1, -2, 4, 0, and -3. Now that's not really the best way to make that domain, right? We'd want to put it in order, least to greatest. So we'd say -3, -2, 0, 1, and 4. So the domain is the list of all x values in a relation. And a relation is a set of ordered pairs that belong together that represent something. Then there's this idea of range. Now, this range is different than the data and statistics range. This range is algebra range, right? This is a function range, which if the domain is the list of all x values in a relation, the range of a relation is a list of all y values in a relation. So we would say from this relation, 5, 3, -1, 7, and 1. But again, that's not the way that we should write it. We should write it in order from least to greatest. -1, 1, 3, 5, 7. So relation is the group of ordered pairs, the domain is the entire list of x values, and the range is the entire list of y values. So that's a relation, right? Relation right here. Now we're going to talk about functions, because a relation can be a function. It might not. It might not be a function, but it can be a function. So the idea of a function is each x value in a relation has one y value. So each x value has one y value, meaning, right, it's kind of hard to visualize that when we don't know what it is. It means that the x values do not repeat. So if each x value is different in a relation, it's considered a function. If an x value happens twice, if an x value repeats, it's not a function. So up here, my x values are 1, -2, 4, 0, -3, right? -3, -2, 0, 1, 4. They're all different. There are 5 ordered pairs, and all 5 x values are different. So this is, yes, a function. If one of the x values repeated, you'd say, no, it's not a function. Down here for the range, we don't worry about the range values when determine a function. A function only worries about the domain or the x values. You've seen this before on your bell work, is this thing called function notation, which is just a fancy word for it's an equation. But function notation, an equation, is written f of x equals. This is function notation. It means the function of x in the problem. What does x do? The function of x. What does x do? What does it make happen? So I could say if x equals 3, find f of x, the function of x, in 2x plus 10. So the function of 3 is 2 times 3 plus 10. The function of 3 is 6 plus 10. The function of 3 is 16. What does the x do? The x value of 3 makes it 16. All you're doing is substituting. Right? Then we can write this as an ordered pair. My x value is 3. My answer, my y value is 16. Function notation, it asks us, it says it's a function. And if it's a function, it means it's a relation where the ordered pairs belong together. It represents something. So if it says, if your x value is 3, find the function of x. What happens when x is put into the problem? Well, x is put into the problem, 2 times 3 plus 10. The answer is 16. So my ordered pair answer, when x is 3, the answer is 16. Function notation is just about substituting. So you could see functions or relations in a few different representations. You could see it in a table. and it will ask you, is the relation a function? So if it's in a table, and remember, your x values need to be in order. If your x values in order and your y values just belong, don't worry, don't mix up your y values. Order a table. A table goes in order of x values. So 1, 3, 7, 10. So they'd say, is this table, are my x values in order? Yes, I'm good. My y values belong with it, so I don't worry about that. My table, is this a function? Yes. How do you know? Because the x values do not repeat. And if I look, my x values are all different. So yes, this is a function. Or you might see what's called a mapping diagram. Mapping diagrams are a little out there. But once you know what it looks like and what it means, it makes sense. So we're going to do this same over here. So it's like an input-output table, right? I have my x values, and sometimes it's like in a little circle or something like that. And then I put these in order. Let's do different, let's change this real quick. Let's make this an 8. That was a 1, that's an 8, that's a 7, that's a 10. Let's make this -7. Is this still a function? Yes, because the x values don't change. But these now, in a mapping diagram, both x and y are in order. So over here, I'm going to put these in order of -7, 1, 8, and 10. And then you draw arrows between the pairs. Oops, there's 2 E's. Ordered pairs. So -3 goes with 1. -2 goes with 8. 0 goes with -7. And 1 goes with 10. Now, if you had like a double, like if there were 2 -7s in your y values, you'd only put 1 -7 and 2 arrows would go to it. Or if one of your x values repeated, if there were 2 zeros, you'd only put 1 0 and you'd draw 2 arrows from it. So is this a function? Do the x's repeat? No, the x's don't repeat. So each x is different. So yes, this is a function. So your x values, that's what you're looking for, the x values. The x values must be all different in order for it to be a function. Let's turn to page 22, and you are going to glue the vertical line test in. I'm going to glue it at the end just because it's easier for me to write in it without it being glued. So again, it says a vertical line test is determined if a graph has a function. So we've talked about a table, we've talked about a mapping diagram, we've talked about a set of ordered pairs. Now we're going to talk about graphs. So remember, a function, each x value has one unique y value, meaning no x values repeat. When the data is in a relation, a table, or a mapping diagram, it's easy to determine because you just look at the x values. Are the x values all different? Graphs are more difficult. So if they gave you like a set of ordered pairs, like so, do you want to draw a graph and plot them and try to figure out? No. I mean, that's crazy, right? So you would look at the ordered pairs and determine it. But what if they gave you a graph, right? Do you want to write down every ordered pair in a line and then look to see? No, I don't want to do that. So we use this thing called the vertical line test. So the vertical line test is if the vertical line, your pencil, touches only one location at a time. It is a function. So you're going to use your pencil or pen as a vertical line, and you're going to drag it vertically up and down across the graph. And if as you drag it, it only touches the graph one spot at a time, yes, it's a function. It's not a function if the vertical line touches more than one location at a time. All right, I'm going to grab a paper clip to show you a little more precisely what this looks like. So we're going to determine yes or no, are these functions? So here's my vertical line, right? Vertical. And I'm going to drag it vertically across the graph. And I'm going to stop right there, because is my vertical line touching the picture, the graph, in more than one location? Yeah, it's touching right here and right here, or right here and right here, or right here and right. There's a bunch of them that they could be touching. So no, this is not a function. So here's my graph right here, right? I'm going to drag this. Does it ever touch that diagonal line in more than one spot? No, it's one location at a time, so it's a function. Okay, let's look. Here's my line. Here's my function, or not a function, right? We're testing it. That's my relation. So let's see. It's only one at a time, so it's a function. This shape is called a parabola. Let's try it. We're good. That's a function. How about this one? Let's look. Right there. I'm touching, or here, right? And there's a lot of them. So no, that's not a function. This one. That's a function. It's kind of hard to tell down here, but this is a triangle. So we start, and nope, right there, I've got two spots in a row, or somewhere else, not a function. Yes, a function. Not a function. So let's recap. A relation, set of ordered pairs in brackets. The domain is the list of x values. I'm using the wrong notebook. The list of x values in a relation. Put them in order. That's the domain. A range is the list of y values. In a range, you put them in order. A function is when each x value has its own y value, and that means the x values do not repeat. So each x value is different. If it's function notation, it's going to say f of x, and then you're going to do some substituting. So if x equals 3, find the function of x, substitute, get an answer. We've got a table that can represent a function. Remember, your x values are in order in a table. And yes, this is because each x is different. We've got a mapping diagram where the x and the y are in order, and you draw arrows to what they belong to. And if one of them repeats, you only put that number once and then draw arrows, 2 arrows from it. And then we have graphs. And to tell if a graph is a function, you do the vertical line test, where you drag your pencil across the graph and determine yes or no. Yes, it's a function if it only touches the graph 1 point at a time. But if it's ever touching 2 points at a time, that means that 2 x values are repeating, or 3, or however many times it touches, and it's not a function. So we're going to glue this on page 22, and then you can start your homework.